Okay, so in this video, I'm going to be doing every question that has ever been asked so far by Edexcel about trigonometry, and in particular, I'm going to be focusing on SOH CAH TOA. So I'm going to be doing these simple ones, some problem-solving ones, and some 3D problem-solving, and then I'll do the exact values and the other ones in separate videos. If you do want to use this document, it is linked in the description, and it has all these questions followed by the mark schemes as well. So this first one we've got here, nice and simple. We've got a right angle triangle, and we want to find out the length of AB, which I'm going to label as x. All you need to think about in this question is that we have got 15, which is the hypotenuse, and the one that we're trying to find out is the opposite. So when you think out of SOH CAH and TOA, in fact, I've actually got it written up here at the top. The one that we're going to be using has the opposite and the hypotenuse, so it is going to be sine. This means that the sine of 23 degrees is equal to the opposite divided by the hypotenuse. And it's because of the order that we've got in here, opposite over hypotenuse. So I'm actually going to write, instead of h, I'm going to write that it is over 15. So what I'm going to do now to find out what x is I just multiply up by 15 so that I get 15 sine 23 is equal to x. And I'm just going to type that on my calculator and see what it comes up with. So I'm going to say 15 sine 23, and to three significant figures, that is going to be 5.86 centimetres. Let's double check we've got this one right by having a look at the mark scheme. Yep, there is the 5.86. Okay, this one says ABC is a right angled triangle. Work out the size of angle ABC, which is the thing I'm going to call x there. And it wants our answer correct to one decimal place. So relative to the angle, this one is adjacent to it, and obviously this one is the hypotenuse. So this is going to be the adjacent and the hypotenuse, which means out of these three, I'm going to be using cos. So this tells me that the cos of my angle is the adjacent divided by the hypotenuse. Now, if you want to find out x, which is inside the cos function, you have to apply the inverse cos function to both sides. So I'm going to be applying the inverse cos function to 7 over 11, and that's going to give me what the angle is. So I'm just going to put it onto the other side of the calculator. I'm going to do the inverse cos of 7 over 11, and I've got the correct answer to one decimal place is 50.5 degrees. It then says for the next part, the length of side AB is reduced by 1. The length of the side BC is still 7. Angle ACB is still 90. Will the value of cos ABC increase or decrease? And you must give a reason for your answer. So previously, our cos x was equal to 7 over 11. And now they've said that the side length of AB is going to reduce by 1. So it's not going to be 11, it's going to be 7 over 10. So our new one will be 7 over 10 instead of 7 over 11. So has it increased or decreased? Well, what we can do is check what these values are on the calculator. So if I do 7 over 11 as a decimal, that is 0.63 or 0.6363 like this. And if I do 7 over 10, I know that that is 0.7. So has it increased or decreased? It has increased, as 0.7 is greater than 0.63. 0.6363. I'm going to put those dots there as well. So we've got 50.5 for the first part, and it has increased because 0.7 is greater than that one. So we did get that part there correct. Okay, I'm just going to put the calculator back to the other side, and we just want to calculate the length of AB. So it's a nice quick question. That's the side I'm looking for, so I'll call it x, and I'm going to identify what I've got relative to this angle. Well, the x is the opposite, so that's going to be the opposite, and this is the hypotenuse, which means out of the three we've got is sine. So I get that sine 38 is equal to the opposite over the hypotenuse, and to find out what x is, we multiply both sides by 16, so x is 16 sine 38. Let's put that in the calculator. 16 sine 38 to two decimal places is 9.85 centimetres. Let's double check we've got this. Yep, there is the 9.85. Okay, now let's have a look at the next question. It says work out the value of x. Okay, so pretty similar setup. The x is the opposite and this is the hypotenuse. So we're going to say that the sine of the angle, the sine of 34, is the opposite over the hypotenuse. I'm going to multiply both sides by the 178 because it's being divided by that. And then I'm literally just going to type that on my calculator. So I'm going to do 178 sine of, oh, that's cos, 178 sine 34. And to one decimal place, that is going to be 99.5 millimetres. Let's see if we've got that one right. Yep, there is the 99.5. Okay, here we are going to work out the length of BC. So we're going to label that that is BC. And relative to this 56 that we've got here, this is going to be adjacent and this is going to be opposite, which means we're going to use tan. So the tan of 56 is equal to the opposite over the adjacent. I'm going to multiply by the 12 so that x is tan 56, 12 tan 56. So I shall type 12 tan 56 into the calculator and I get 17.8 to 1 decimal place. So that is 17.8 centimetres and that's to 1 decimal place. This time they want us to work out the angle. So relative to the angle, this one is next to the angle, so it's the adjacent, and this is the hypotenuse. So we're going to say that the cos of x, because obviously for this question we're going to be using the CAH for the next part, C, A and H. The cos of x is equal to the adjacent divided by the hypotenuse. So to find out what x is equal to, we do the inverse cos of 15 over 18 because we're trying to get x by itself. So I shall do on my calculator shift and then cos to get inverse cos, and I will do 15 over 18. And that gives me the answer to 1 decimal place, 33.6 degrees. Let's double check we've got these. So we've got 17.8 and 33.6. Yep, there they are in the answers that we have. Okay, more problem solving actually coming up in these, not just the straightforward kinds of questions. So they've told us some of the information already. It's a right angled triangle and this is 14 and this is a right angle. Here's the extra part though. It says that the size of angle B and to the size of angle A is 3 to 2. Now you could do this with algebra. You could say that if this one is 3x, then this one down here is 2x. And I think that means we need to find out what those angles are, and then we're going to try and find out the length of AB that we have over here. So let's begin by thinking about what we've got going on inside the triangle. These three angles are going to have to add up to 180. So we're going to say that 90 plus 3x plus 2x has got to be 180. Well, if I take away the 90, I would get that 3x plus 2x has got to be equal to 90, and 3x plus 2x is 5x. So x is 90 divided by 5, which is 18. Again, you could do that on the calculator. So I'm just going to find out what either one of these two are. I'll tell you what, I'll find out what 2x is. So that one is 36. So I can replace this with a 36. And actually, I'm not going to need the other ones. I'll tell you what, why don't I do that 36 in a red colour, and then I'll do the rest of the question in red. So now that's 36 degrees, and I have got this part along here is 14. And the thing that I'm trying to find out, which is AB, if I call that y, I think the 14 is adjacent to the 36 and the y is still the hypotenuse, so we're going to be using the cosine. We're going to say that the cos of 36 is equal to the adjacent divided by the hypotenuse. Now this is the first example where the letter we're looking for is in the denominator, so there's a special trick that happens here. You can swap these two over because the y multiplies up and the cos 36 multiplies down. So we get y is equal to 14 over cos 36. I'm just going to type that in and we'll see what we get. So I'm going to do 14 over cos 36. And to three significant figures, that is 17.3 centimetres. And I'm pretty happy with that answer because the hypotenuse is always longer than the other sides. And if this one is 14, it's good that I've got an answer that's longer than it. Yep, there is the 17.3, and if you want to pause this, you can always look at the mark schemes as well. Okay, this time it says that ABCD is a trapezium. Work out the size of angle CDA. Give your answer correct to 1 decimal place. Okay, well, I think I'm going to try and see how I can find this out. I want to find out the size of angle CDA. That's this angle over here that we're going to look for. That's the angle X that I'm going to do. Well, I think if I need to do that, I need to know some lengths of the triangle that I've got at the end. And when I'm talking about the triangle at the end, I'm talking about this triangle that we've got here. Well, one of them is nice and easy. I know that this is going to be a 6. And what I need to do is try and figure out the length of this part that I've got at the bottom here. I guess I could use the fact that this is 24 and this is 10, but that's actually not going to be enough to just tell me this length. I think I need to find out what this length over here is. So I'm going to begin by finding out what this length is. And I think this length, if I call that, say, y, I'm going to say that y is equal to, I'm going to use Pythagoras here, I'm going to do the square root of 7.5 squared minus 6 squared. I'm not looking for the longest side, I'm looking for one of the shorter sides, which is why I've got it written with that sort of subtract sign instead. So I'm going to do the square root of 7.5 squared minus 6 squared, and that gives me the answer 4.5 centimetres. So now I know that this part is 4.5 centimetres. I know that this is 10 centimetres, so this is 4.5 and this is 10, so I should be able to find out the bottom part of this triangle. The bottom part of this triangle that I've got here is going to be 24 minus the 10 minus the 4.5. So 24 minus 10 minus 4.5 is going to be 9.5. So I now know that the bottom part of the triangle is 9.5, which means I can draw out that triangle again. The bottom part is 9.5, the side part is 6, and the thing I'm looking for is x. So this one is going to be opposite the angle, this one is adjacent to the angle, which means I'm going to be using TOA. So the tan of x is equal to the opposite divided by the adjacent. It always follows the letter order that you have here. And so x is going to be the inverse tan of 6 over 9.5. Let's see if we can get the right answer. So we're going to do the inverse tan of 6 over 9.5, and we get 32.3 to 1 decimal place. So our answer is 32.3 degrees to 1 decimal place. Let's see if we have got the right answer. There's that 32.3, and you can see we had to do some Pythagoras at this part that we've got here. So technically there's some Pythagoras going on in this question too. Okay, this one we've got a few different triangles that are kind of all stacked together. Let's just quickly read through what it says. Basically it tells us that ADC and DEB are straight lines. Well, I can see that on the diagram. It tells us this is 4.4, this is 8.6, but this is the important part. It says that E is the midpoint of DB. So I'm going to just quickly mark on here, these two are the same as each other. It tells us this angle is 90 and this angle is 40. That's this last part. And the thing that we're going to try and find out is the size of angle EAD. EAD meaning this angle that we've got over here. So we're going to try and give our answer to 1 decimal place, and we're going to show all of our working. Well, this is going to be the triangle that eventually I want to use. Now, I don't actually have enough information about this triangle because I don't know how tall this bit is. So I'm actually going to look at this big triangle that I have on this side, and that might help me find out how long this side is, which then I can half to find this side, and then I've got enough information to do SOH CAH TOA. So let's look at this big triangle. I'm going to quickly just draw out the big triangle again, and that is where I have the 8.6 and the 40 degrees. And because I've already used the letter x, I'm actually just going to use the letter y on this side. Now this is opposite 40, the y, and this is the hypotenuse, so it is the sine example that we've got here. So the sine of 40 is equal to the opposite divided by the adjacent. So now multiply by 8.6, I get 8.6 sine 40 is equal to y. I'm just going to type that in on the calculator that I've got here. So I'm going to do my 8.6 sine 40, and I get 5.528. I'll do a few decimal places just so I've got enough. So that's 5.528, 5.528. Now I'm going to do this next triangle that I've got here, bearing in mind though that this length is going to be a half of this length that we've got here. So this was my yellow triangle. Now I'm going to do the smaller triangle, which is the blue one that I've got down here. So I have 4.4 along the bottom. What I'm going to do is I'm going to take this one, I'm going to divide it by 2, and it will give me that length that I'm looking for along the side part. So I've already got it stored on my calculator. I'm going to do that answer divided by 2, and that is 2.764 to 3 decimal places. That is 2.764. So all I need to do for this blue triangle that I've got down here at the bottom, I need to do another SOH CAH TOA. This time I have got the opposite and the adjacent, which means I'm going to be using the TOA part, or the tan part. So I can now say that the tan of x is equal to the opposite divided by the adjacent, and so x is the inverse tan of 2.764 over 4.4, and we can just go straight from there and see what our answer is going to be to 1 decimal place. So I'm going to do the inverse tan of, as a fraction, 2.764 all over 4.4, and to 1 decimal place, because we did enough decimal places earlier on, we've now got it as 32.1. So x is 32.1 degrees. Let's see if we have this one the same as them. There's 32.1 degrees, and if you want to, you can see the method, but hopefully my method will be clear enough for you to see how it's done. Okay, although this one features exact values, I think it's more about problem solving, so we're actually going to put it in this category, and it's a non-calculator one. Here is trapezium ABCD. The area of the trapezium is 66. The length of AB to the length of CD is 2 to 3. Find the length of AB. Okay, well, first of all, we need to remember some things about the area of a trapezium. The area of a trapezium is a half A plus B height, which sometimes people write as the average of A and B multiplied by the height. And the A and B are going to be this side and this side that we've got here. Now, they've said that the length of AB to the length of CD is 2 to 3. So that means this is like a 2x part, and this is like a 3x part, because if you have the ratio 2 to 3, 2x to 3x is in that same ratio that we've got there. Now, because we know it's about the area of a trapezium, looks like we've got what A is and what B is, but I don't have what the height is. So I'm going to say that the height is the gap between them. Now, you might think, should I write the height here? Or even better, maybe I'm going to put the height at this point. And I think the reason this is better is because what I then create is this. I create a triangle where I can use SOH CAH TOA. So when I draw that triangle out, well, I don't even know if I need to be honest. I'm going to try and find out what the height is. So looking at this one, I have got the hypotenuse of that triangle, because this is a right angle, and I have got the opposite. So I'm going to be using sine. I know that the sine of 30 is going to be equal to the opposite, which is h, divided by the hypotenuse, which is 6. So I'm going to multiply it by 6, so I get 6 sine 30 equals h. Now, because it's a non-calculator paper, we're going to try and remember the fact that sine 30 is equal to a half. You can check that in your calculator, but we don't have one for the exam. But sine 30 equals a half is something that you need to remember. So that's going to be 6 multiplied by a half is the height, which means that the height is equal to 3. In fact, I'm going to grab all of that, I'm going to put it down here. So now I know that the height of this trapezium is 3. I'm actually going to redraw the whole trapezium diagram, because I think it's going to make the next step even easier. I know that this is 2x, and this is 3x, and the height is 3. I'm going to use the formula of this and the fact that the area is 66. So the area of a trapezium is going to be A plus B over 2 multiplied by the height, which is 3, and that is equal to 66. This, I'm going to use a different colour, this formula is this formula that we have here. I've done A plus B divided by 2 times 3 equals 66. So I'm going to try and solve this equation. First of all, I'm going to simplify it. So I'm going to say I've got 5x over 2 times 3 equals 66. Well, I'm going to get rid of this times 3 by dividing by 3. So 5x over 2 is equal to 22. Now I'm going to get rid of this divide by 2 by multiplying by 2. So 5x is equal to 44. And so my almost last step is to do a divide by 5. So I'm going to do 44 divided by 5. See if I can squeeze that in down this bottom part. Well, 5 goes into 44, it goes in 8 times, remainder 4, and it goes into 40 8 times. So x is equal to 8.8. Now they want us to say the size of AB. They said find the length of AB. So AB is equal to 2x, which is equal to 2 times 8.8. So if I just do 8.8 times 2, I'm going to get 2 times 8 is 16, 2 times 8 is 16, and the 1 is 17, so I get 17.6. So it is 17.6 centimetres for this. I'm going to just erase these so it's a little bit cleaner for us to look at, but we've got the answer 17.6, and you can see that right here. Okay, we're going to keep going. We're going to do this 3D problem solving one with SOH CAH TOA. It says that AB is 7.3, so I'm going to draw that on the diagram. CH is 8.1. And angle BCA is 48. So BCA is 48. That means I'm going to have to draw in this sort of diagonal line here. And this one is 48. So this one that I'm talking about is kind of flat on the floor. And we're going to try and find the angle between AH and the plane ABCD. So I'm going to draw in the line between A and H. What we're going to try and do is find out this angle here. Now this angle that I'm talking about is between AH, and it's also in between that line on the bottom. So I'm going to take this flat triangle that's sort of like resting on the floor. I'm going to draw that out and see if that might help me find out some of the lengths that I might need here. I think I'm going to need this length because that way I've got an 8.1 and it can help me find out the angle. So the yellow triangle that I've got is A, B and C. There's A to B and there's B to C. We know that between A and B it's this 7.3, so I'm actually going to write that a little bit closer to it. So there's the 7.3. I'm never going to be able to get that removed from it, am I? There I am, good. So that is the 7.3, which is between A and B. And then this is C, and that is 48. Now I want the length of this line because then I can use it in the second triangle. So I'm going to try and find out the length of this side. And I have got here, saving a bit of time, I have got the opposite and I've got the hypotenuse, so it's going to be the sine. So the sine of 48 is equal to the opposite divided by the hypotenuse. These two switch places, and so x is equal to 7.3 over sine 48. 7.3 over sine 48. Okay, let's see what we get, and it is 9.823. 9.823. So now when I look at this big triangle that I've got here, I actually know what the distance between A and C are because I've just worked them out. So when I draw out that big triangle, I have A, I have H, and I have C. The angle that they want us to find, let's just call it Y, because it's the angle between AH and the plane ABCD. Well, I know that this is 8.1, I can see it on the diagram, and this is the one I've just worked out, which is my 9.823. So to find out what y is equal to, well, this time I've got the opposite and I've got the adjacent. So I'm going to say that the tan of y is the opposite divided by the adjacent. So y is the inverse tan of 8.1 over 9.823. And that's going to be our answer to this question. So I'm going to do the inverse tan of 8.1. You could use the more accurate version, which is the one that's stored in my calculator as the answer, but just to show you it's not going to make a difference because I did enough decimal places, it's going to be 39.5 degrees. So we get 39.5 degrees. Let's check we've got this one. Yep, there is the 39.5 that we have there. Okay, I think this is our last one on, there's two more on 3D problem solving and I think we're done. So it says here is a pyramid with square base ABCD. AB is equal to 5, so this is 5, and the vertex T is 12 meters vertically above the midpoint of AC. So from here downwards is going to be 12. Now there's some stuff we need to work out. We want to work out the size of angle TAC, so TAC. So in order to work out the size of angle TAC, I think I'm going to need to work out what this length is along the bottom. And the way I'm going to do that is actually using some Pythagoras. If I draw out this triangle, which is A, B and C, it's going to look like this. So there's my A, my B and my C. This is the blue triangle I have here. The sides are 5 and 5. So if I want to find out how long AC is equal to, I'm going to do the square root of 5 squared plus 5 squared. So that's the square root of 5 squared plus 5 squared. It's going to be the square root of 50. Square root of 5 squared plus 5 squared is 7.07. So this is 7.07. Now the angle that I'm trying to work out is the angle TAC. So there's TAC. I'm not going to go all the way across to C because I'm going to draw this triangle that we've got here. Now this triangle, if I call this M for the midpoint, if I draw out that triangle, I have T, I have A, and I have M. And this 7.07, I'm actually going to divide it by 2 because it's the midway point. And half of it, if I divide it by 2, is 3.535. So I'm just going to say that that is 3.535 ... Keeps going, that number. And we're going to try and find out what the angle is over here. Luckily, I know that the length of T to M is 12. So if I'm going to find out what this angle here is, which is x, I know that tan x is equal to the opposite over the adjacent, which is my 3.53. I guess I could show over here 7.07 divided by 2 is my 3.535. 3.535. So x is the inverse tan of 12 over 3.535. Get it onto the calculator, and we're going to just do it to one decimal place. So inverse, the inverse tan, come on calculator, inverse tan of 12 over 3.535, and to one decimal place I'm going to say it is 73.6. So 73.6 degrees. Let's see if we've got this one right. Yep, there is the 73.6, and you can always look at the mark scheme if you want to. Okay, we are nearly here. It says the base, the diagram shows a triangular prism. The base ABCD of the prism is a square of side length 15. That's important. Angle ABE and angle CBE are right angles. Okay, so angle ABE and the other one is CBE. CBE, I see. So that's a right angle at the back. Angle EAB is 35 degrees, I can see that there, and it says that M is on the point DA such that DM to MA is 2 to 3. So that means that it is closer to D than it is to A in the ratio 2 to 3. So I'm going to put M here. Calculate the size of the angle between EM and the base of the prism. So the angle between EM is going to be this angle that we have here. There's EM. And then the base of the prism, I'm going to do from M over to B that we've got at this point here. So I think in order for us to do this, I need to know some of these lengths that we might have. So I think we should probably calculate, I want to find out the length of this line that we've got. And to do that, I'm going to have this triangle that we've got here. And then I think we're going to need to find out the length of probably this part at the back. And we'll do that one in just a second. So I'm going to draw out that triangle that I've got. It has got a right angle in the corner, so it's not going to look exactly the same as I've just as is in the diagram. But there's a right angle over here which is at A, and that's B, and that is M. Now we know that this side is 15. This part isn't going to be 15 though. Because it's in the ratio 2 to 3, I'm going to find out how much one part is and I'll share it out. So I'll do 15 divided by 5 to find one part, which is 3. So the ratio is 2 to 3. If I times it by 3, I get 6 to 9, which means this part is 6 centimetres, and so this part is 9 centimetres. So I can put that 9 centimetres on the diagram here. Now I'm going to find out that length MB. This is a very difficult question because it's right near the end of the paper. I'm going to do Pythagoras to find the length of MB, which is going to be 9 squared plus 15 squared square rooted. So I'm going to do the square root of 9 squared plus 15 squared, and I get 17.492, or 17.49 will be enough. So that is 17.49. I've now got that length. I think what I need to do is find out another length so that I have enough from the triangle. So this time I'm going to look at this triangle, which is my ABE triangle. I have ABE. This is 35 and this is 15, and I want to find out this length over here. So this is going to be an opposite and adjacent. So the tan of 35 is the opposite over the adjacent, and so x is 15 tan 35. So putting that in the calculator, 15 tan 35 is 10.50, or just 10.5 that we've got. So now I'm going to do in my final colour, I'm actually going to do the triangle that we have here, because I now know all of the lengths. So for that triangle that we've got, I've got running along the bottom is MB, and MB we worked out earlier on is 17.49, and then BE that we've just worked out is X, which is 10.5. So we're going to find the angle between EM and the base, which is going to be this angle, which I'm going to call Y. So I know that tan Y is the opposite over the adjacent, which means that Y is the inverse tan of that. So I'll put that on my calculator, and hopefully that's going to give us the right answer. So it's 10.5 over 17.49. The inverse tan of 10.5 over 17.49. And to one decimal place, actually that's going to round up to a 31.0. So this is 31.0 degrees. Let's hope this is right. Yep, there is the 31.0. I think they make you work really, really, really hard for this. It's possible there's a quick way. This is just the way that my mind kind of sees this working. So the next parts are going to be, oh my God, there's one more question. Okay, I'm going to do this one super fast. So volume of a prism, and it says the cross-section of the prism has exactly one line of symmetry. We want to find the volume of this. Work out the volume of the prism. Okay, well, first of all, the area of this section is very easy. It's just 12 times 10, which is 120. I'm going to try and work out the area of this triangle. Now, I know something about that triangle. If I draw it out over here, I need to find out the height of the triangle, and that is 40 degrees, and along the bottom is 10 centimetres. So what I'm going to do is I'm just going to look at this little section, and I'm going to say that this is 5 centimetres. So when I draw this triangle, if I draw it out again, there's a 40, a 5. I want to find out what the height is. So I know that the tan of 40 is equal to the opposite over the adjacent. So h is 5 tan 40. And 5 tan 40, you know what, I can just leave that, and I'm going to just use that during the question. So I'm going to do the volume of the prism. The volume of the prism is the area multiplied by the length. The length in this case is going to be 20. So the area that we have at the beginning is 120 plus the base of this triangle, which is 10, times by the height divided by 2. So that is going to be the 10 times by the height divided by 2. And all of that is going to be multiplied by the length, which is 20. So in the sake of speeding this up a bit, I'm going to do this all in one single calculation. I'm going to do the 120 plus the triangle, which is 10 times 5 times tan 40 divided by 2. So that's the area of the cross-section. I'm going to multiply that by 20. And I get the answer 2819.5, but it wants it to 3 significant figures. So 3 significant figures means the 9 is going to make that round up to a 2. So it is 2820 centimetres cubed, 2820 centimetres cubed, which we have here. This was a very long video. The rest are going to be on exact trig values. If you found this useful, it probably got a lot harder towards the end. If you found it useful, please do like the video. Please do consider subscribing to my channel. And well done on doing a big chunk of revision on SOH CAH TOA. There's some pretty tough questions in here.